During our unit on linear functions and equations, we've discussed the purpose of a y-intercept. We've also discussed its location in a linear equation, as well as what it means on a graph. To this point, we've stated that a y-intercept is where our function is going to cross the y-axis. Now, of course, we can infer from this, if the y-intercept crosses the y-axis, then our x-axis is going to be where our function crosses the x-axis. Pause the video to take a moment and graph the 4 linear equations that are on your paper. If we look at our first line, we can see that our y-intercept is 0, 4. Now remember, this is where our line crossed the y-axis. We can also see that our line will cross the x-axis at the point of 2, 0. If we look at our second graph, we can see once again that our y-intercept is 0, negative 8. And we can see that our line will cross the x-axis at negative 2, 0. In the third graph, we can see that the y-intercept is 0, negative 2, and it is going to cross the x-axis at the point 6, 0. And in our fourth graph, we can see the y-intercept is 0, 2, and the line will cross the x-axis at 5, 0. Let's take those values, all those coordinate pairs, and examine them much more closely. I want you to take a moment now, pause the video, and examine all of the ordered pairs for the y-intercept. See if you can find a common piece in all of them. At this point, you should have been able to see that at each point, in each ordered pair, the x value will equal 0. So for a y-intercept, x has a value of 0. Let's take a moment and look at our x-intercepts as well. Pause the video and see if you can find a commonality among the ordered pairs and develop a hypothesis. You should have noticed that for all 4 of our ordered pairs, the y value is going to be 0. Therefore, if we are dealing with an x-intercept, we will have a y value of 0. Let's go ahead and find the x and y intercepts for the same 4 equations without using a graph, without seeing this picture. Let's use algebra. We're going to use the 2 hypotheses from before. The first being, for a y-intercept, x has a value of 0. For this, we are going to do a little bit of substitution and apply order of operations. So to find our y-intercept, we are going to substitute the value of 0 for x. Pause the video and work that through. You should get that y will end up equaling 4, which means we'll have a point of 0, 4. Since the x value was 0, and the y value will end up being 4. We can do the same thing for our x-intercept. But in this case, instead of putting 0 in for x, we are going to put 0 in for y. This is a little bit more involved because now we have ourselves a two-step equation. Pause the video and attempt to solve this equation. As you solve this, you'll get that x is equal to 2, which means that our x-intercept was the point 2, 0. Now, if we look back at our information from before, for the equation y equals negative 2x plus 4, we had a y-intercept of 0, 4, and an x-intercept of 2, 0, which is exactly what we solved for just now. Go ahead and pause your video and attempt to find the x and y intercept in the same fashion for the remaining. After working through each of these, by applying order of operations after substitution for the y-intercepts, and for solving a two-step equation after substituting 0 for y for the x-intercept, these are the values that you should have found. At each instance, we see that the x and y-intercepts match up with what we were able to observe from the graph. Let's take a look at this last example. Y equals negative 3x plus 12. Once again, we are going to find our x-intercept, and we are going to find our y-intercept. Pause the video and work this through now on your own. This is what you should have found out at the end of your work. Now remember, when we solve for the x-intercept, we get a value for x. That's our x-intercept. Our y value is always 0. So the point in this case is 4, 0. Similar situation occurs with our y-intercept. When we work through this problem, we get a y value. At a y-intercept, we remember that our x value is always 0. Therefore, our y-intercept is the point 0, 12. Let's take a look at one more interesting occurrence. Let's create the equation y equals 6 as a graph. This is interesting. Let's expand it into slope-intercept form. Right now, all we have is a coefficient. Therefore, we know that our slope is going to be 0 by applying our multiplicative property of 0. Because 0 times x will effectively give us 0. Identity property of addition, 0 plus 6 leaves us with 6. Now, of course, 0 is a number that can be written as a fraction, 0 over 1. Let's go ahead and start to graph this then. When y equals 6, 1, 2, 3, 4, 5, 6, there's our y-intercept. But wait a second, if we follow our slope, we have 0 change in the y-axis, yet a change of 1 in our x-axis. What kind of line have we created? It seems that we have a horizontal line that is parallel to our x-axis. Since it's parallel, it will never cross the x-axis. Therefore, we will never have an x-intercept for this graph. So our x-intercept here is none. Let's take a look at a linear equation written as x equals negative 3. We'll put a point in here first. X definitely equals -3 right here. That's a true statement. But now let's make ourselves a table of values. And we're actually going to work in reverse this time. When y equals 0, we go to substitute this in. What is x going to equal? There's nowhere to substitute the y, so the statement remains true. Let's put 1 in for y. Nowhere to substitute it in, our statement remains true. X is still -3. Let's put 100 in for y. Still nowhere to put this value in for y. Thus, x will still equal -3. This means no matter where we put y, no matter where we have a y value, our x value will continue to be -3. Meaning that we have a straight vertical line. And this line will continue to go through every single section where x equals -3. That being said, let's find our x-intercept. Where does this line cross our x-axis? Well, it seems to happen right here. Therefore, our x-intercept is -3, 0. But what about our y-intercept? If we look at this line, we can see that it's parallel to the y-axis. If it's parallel, it's never going to cross the y-axis, meaning that we have no y-intercept. Let's examine the slope. Remember that slope is our change in y values over our change in x values. How do our y values change each time? Well, if you go up 1, but has our x value changed at all? In this case, no. And we can continue to follow this pattern. Each time, the y value can change by 1, however, our x value will not change at all. This right here is an evil number. This is known as undefined. We are not allowed to divide by 0 in mathematics. Thus, we call this slope undefined, which means anytime we see a line that is straight up and down, meaning a vertical line, we're going to have an undefined slope. Now I want you to think about whether or not this would qualify as a function. Remember to apply all of your learning up to this point about functions and how to determine whether or not a line is a function.